It's altogether touchy. It's going to explode. No, giving me is not going to be a valuable chance to go for that. The thing is, it might be tomorrow. It very well might be during this transmission, and it would shimmer like a subsequent sun above. The James Webb Telescope has, as of late, identified an unforeseen 250% development in the brightness of Betelgeuse, the red star arranged at the shoulder of the Orion star gathering. This capricious approach to acting has lighted energy for a captivating showcase. Some suggest the flood in splendor could show Betelgeuse is getting ready to go supernova, yet the particular time remains questionable. Experts estimate it could occur in a little while. Join us as we investigate the profundities of space and loosen up the privileged insights incorporating this grand Goliath. Scarab juice has the potential to reshape how we comprehend the universe. Regardless of its name not being well known, you've presumably appreciated its magnificence. A splendid bronze sparkle shining brightly at the shoulder of Orion, an outstanding star gathering. Scarab juice's tremendousness is faltering. Whenever set at the core of our planetary framework, its external surface would reach out past Jupiter's orbit. This giant star, easily observable, continues to enchant us. Unlike most stars, Betelgeuse changes obviously over time due to its proximity to our system. Named a semi-regular variable star, its brilliance fluctuates consistently, pushing toward an expected perfect breakdown in a cosmic explosion. Recently, Betelgeuse has become much more dazzling because of astonishing changes in brilliance. These fluctuations include a huge flood on May 20, 2023. Scientists, dumbfounded, noticed a faltering 142% increment in splendor, followed by a later update showing a 150% increment. An astrophysicist from the Harvard Smith Center for Astronomy, Dupree, noted that Betelgeuse currently ranks as the 7th most brilliant star in the night sky, climbing 3 spots from its standard 10th position. From the southern portion of the globe, Betelgeuse sparkles brilliantly in the evening sky, easily noticeable at the shoulder of the Orion gathering of stars. Dr. Sarah Webb, an astrophysicist from Swinburne College of Technology in Australia, highlights Betelgeuse's importance. It offers an interesting opportunity to concentrate on the last stages of a huge star's life, providing significant bits of insight into red giants' conduct before they detonate as supernovae. When Betelgeuse eventually explodes, it could turn out to be unbelievably brilliant for about 7 days, conceivably projecting shadows around the evening time. This prospect has both amateur stargazers and expert space experts enthusiastically expecting the occasion. Heidi Morris, a scientist at Los Alamos National Laboratory and president of the PD Stargazers and Cosmology Club, notes the persevering interest in Betelgeuse's brightness differences, a peculiarity seen for quite a long time by various societies. Right now, Betelgeuse's brilliant cycle endures around 130 days, substantially more limited than its normal multi-year cycle. These rapid changes give cosmologists a unique opportunity to concentrate on this divine peculiarity, shedding light on the last phases of a star's life. The amazing way of behaving of Betelgeuse began in 2019 when it fiercely shot out a piece of its external air. These variances in brilliance are unusual for Betelgeuse, raising questions about whether it will explode into a cosmic explosion. As indicated by a paper composed by Dupree and other analysts from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse gets back to its not-expected 400-day brilliance cycle. Since the limit obscuring Betelgeuse has shown altered conduct concerning its light and spiral speed, not enduring its eccentric conduct, Betelgeuse remains a huge red supergiant star going through the last periods of rapid advancement as it exhausts its fuel. The center will fall under its tremendous mass, resulting in a cosmic explosion that could obscure whole worlds. The timing of this impact is questionable, as verified by Dr. Pierre, a professor of cosmology at the University of Portsmouth. Predicting cosmic explosion events remains challenging, given the limited historical data and the complexity of stellar evolution. Betelgeuse is presently going through fusion processes, constantly developing through elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon in its center, a cycle that takes millions of years. Eventually, it will progress to melt heavier elements until it can no longer support fusion reactions, leading to gravitational collapse and possibly forming a black hole or a neutron star. While some theorize about Betelgeuse's approaching blast, historical records show it has been growing redder over the recent years, suggesting it may take considerable time before it goes supernova. NASA estimates proposed that Betelgeuse isn't supposed to detonate for another 100,000 years, offering consolation that its blast is far-fetched to happen within our lifetimes. Disregarding the uncertainty, Betelgeuse's conduct continues to captivate analysts, and advancements in our understanding of stellar evolution are ongoing. Dr. Sarah Webb reminds us to remain open to potential outcomes, even as we recognize the unlikely probability of seeing Betelgeuse's blast in our lives. Staying aware of its progressions may lead to further scientific breakthroughs, reminding us to keep hope alive for new discoveries in the universe. It's crucial to understand that our observations of Betelgeuse are essentially witnesses to the past. The light we see from the star is more than 600 years old. Hypothetically, Betelgeuse might have already detonated, and we wouldn't yet be aware of it. While this possibility exists, it is far from certain. History has shown us that our assumptions in astronomy can be challenged. Prior to 1987, astronomers believed only red supergiants could go through supernovae. However, that year, a giant blue star in another system detonated, astonishing the scholarly community. There is still much to learn, and surprises may lie ahead. Noticing Betelgeuse and other enormous stars allows us to expand our understanding of heavenly peculiarities. Regardless of the shortfall of an upcoming blast, Betelgeuse's current conduct is enrapturing. Its variance between dimming and emitting uncovers captivating physics. The way that stars throb on human timescales is astounding. While Betelgeuse is currently much more brilliant than anticipated in light of its normal multi-year cycle, there's hope it will eventually return to this cycle. However, it is struggling to do so. Later observations have suggested that Betelgeuse might be in a late stage or approaching the end of the carbon-burning core cycle. This stage involves the transformation of carbon into heavier elements like oxygen and magnesium. If this is indeed the case, researchers foresee a core collapse leading to a cosmic explosion that could occur within a couple of hundred years. However, the exact period of Betelgeuse's evolution remains difficult to determine, and uncertainties persist. The chance of seeing Betelgeuse's blast remains unclear, as the carbon-burning stage can last up to 1,000 years, and the study suggesting an impending blast has not yet been accepted for publication. Nevertheless, the potential for Betelgeuse to turn into a supernova is exciting. It would be an extraordinary event, visible even during the day for several days. When the event arrives, the initial signs of the supernova's appearance will be subtle but obvious, with neutrinos clearing across Earth as high-energy photons escape from the expanding cloud of celestial debris. Betelgeuse will progressively grow brighter in the night sky, possibly reaching peak brilliance 10,000 to 100,000 times its normal brilliance within just a few weeks. This scene will astonish anyone fortunate enough to witness it, marking a crucial moment in cosmic history. The remains of Betelgeuse's blast could be as brilliant as a quarter or half of a full moon into a single point of light. Staggeringly, this brilliance would be visible during daylight, casting dramatic shadows at night. Predictions suggest it might be 15 to 20 times brighter than Venus, currently the second brightest object in the night sky. The display of Betelgeuse's blast would persist in our view for around 100 days, captivating space enthusiasts and offering a unique opportunity to observe the aftermath up close. Fortunately, Betelgeuse's supernova wouldn't pose any danger to humanity, as it is still essentially far away. Optics and telescopes would allow us to observe the event for an extended period without harm. However, such a dramatic event wouldn't go unnoticed. Supernovae were often interpreted as ominous signs, and Betelgeuse's destruction could inspire interesting reactions around the world. Astronomers believe it could even reignite broad interest in stargazing, awakening people from their ignorance on a global scale. Betelgeuse isn't the only red supergiant in our galaxy. Others, like Edi Carni, could detonate before it does. In fact, our Milky Way should observe a supernova roughly once every 100 years, yet we haven't seen one in the past 400 years. Still, we've observed the remains of past explosions, showing that we are overdue for a significant celestial event. It's only a matter of time before the next star puts on its grand performance for the universe to observe. Betelgeuse's history is rich with significant events, including the dramatic dimming in the fall of 2019. This sudden reduction in brightness bewildered cosmologists and ignited speculation about its potential explosion. Although Betelgeuse's brilliance returned to normal by April 2020, the reason for its dimming remained a mystery until further observations shed light on the phenomenon. Skywatchers can easily detect Betelgeuse from their patios, providing valuable observations for scientists to gain a deeper understanding of the star and its dramatic changes. Researchers rely on observatories like the Hubble. The interest surrounding Betelgeuse's dimming and potential explosion has captured the imagination of many. The fascination with Betelgeuse has been a continuous source of inspiration for both amateur stargazers and expert scientists alike. The star's unpredictability, especially its erratic brightness variations and mysterious darkening episodes, has made it an exceptional subject for study. Observing these changes not only offers insights into the nature of red supergiants but also provides valuable information about stellar life cycles, the processes that lead to supernova explosions, and the dynamics of massive stars nearing the end of their existence. Betelgeuse's recent surge in brilliance in 2023 has reignited global interest in this astronomical giant. The star's exceptional behavior raises intriguing questions about the timing and nature of its inevitable supernova event. Some astronomers are hopeful that Betelgeuse's brightening is a sign that the star is approaching the end of its life, while others warn that the star might be undergoing an unusual yet normal period of evolution. These changes in brightness offer an exciting opportunity to observe stellar behavior in real time, giving stargazers a chance to test hypotheses about the evolution of massive stars and their eventual demise. Despite the uncertainty surrounding the specific cause of Betelgeuse's recent activity, the star's history continues to provide clues. As mentioned earlier, Betelgeuse has experienced significant fluctuations in brightness over the past few centuries, and its periodic variations are believed to be part of the normal life cycle of a red supergiant. However, the sheer size of the current brightness surge has triggered a wave of excitement among the scientific community, prompting further investigations into whether these changes are harbingers of a supernova or merely the star's typical behavior. As research continues, one thing is clear: Betelgeuse remains an exceptional subject of scientific study. While its inevitable explosion remains a distant possibility, the ongoing monitoring of the celestial behemoth is expected to yield important insights. By studying the behavior of stars like Betelgeuse, astronomers can refine models of stellar evolution, providing glimpses into the life cycles of stars and the cosmic processes that shape our universe. Meanwhile, sky watchers will continue to marvel at the brilliant, fluctuating glow of Betelgeuse. Whether it is darkening or brightening, the star's erratic nature ensures it remains a captivating focus for both amateur and professional astronomers. As we continue to observe its evolution, the potential for a stunning supernova event adds an element of cosmic drama to an already extraordinary celestial scene. Ultimately, Betelgeuse's inevitable fate will significantly impact our understanding of the universe. While we may not witness the star's final explosion in our lifetimes, the knowledge gained from studying Betelgeuse and other massive stars will shape our understanding of the universe for generations to come. For now, stargazers and astronomers alike remain anxiously tuned to the skies, awaiting the next chapter in the life of this mysterious red supergiant. As we continue to observe the behavior of Betelgeuse, its unpredictability remains both fascinating and puzzling for astronomers. While many red supergiants like Betelgeuse show fluctuations in brightness as part of their natural life cycle, the recent events surrounding the star have piqued curiosity about the underlying mechanisms at play. In particular, its rapid and dramatic shifts in luminosity have led to debates about whether these phenomena are simply part of the star's regular cycle, or if they could indeed signal an imminent end to its life. The current surge in brightness is not the first time Betelgeuse has attracted attention due to its unexpected changes. In 2019, the star experienced a sharp and mysterious dimming that baffled researchers, leading some to speculate about the star's impending death. After recovering in brightness, it resumed its irregular pattern of fluctuations, leaving scientists to wonder whether these changes are merely part of an unusual phase, or whether they could be an indication of a significant transformation. Some astronomers have even suggested that Betelgeuse's peculiar behavior might be the result of a complex internal process, potentially involving a massive ejection of material from its outer layers. For now, the primary focus of scientific research remains on understanding the mechanisms behind Betelgeuse's sudden increase in brightness and its erratic dimming episodes. These observations are invaluable in refining models of stellar evolution, helping astronomers understand the processes that lead to a star's death and the eventual formation of a supernova. Such insights could offer a deeper understanding of the life cycles of massive stars and the fate of other stellar giants in our galaxy. As the excitement around Betelgeuse continues to grow, it's clear that this star is not only captivating the scientific community but also inspiring the public's fascination with the cosmos. The possibility of witnessing the supernova event, whether in our lifetimes or far in the future, ensures that Betelgeuse will remain a point of interest for generations to come, offering both scientific insight and celestial spectacle.